All right, number 12, we want to find the inverse of the one-to-one, give the domain and the range, and graph both f and f inverse on the same axis. So we are given f of x equals x plus 3 divided by x minus 2. And we're going to start, let's find the domain. Okay, so domain would include all values that do not allow the denominator to be 0. So anything that makes the bottom 0 would be thrown out. So we start out by focusing on the bottom. So this x minus 2, we cannot let that equal 0. And solving, we can add 2. So we get x cannot be equal to 2. So in our domain, we will remove the point 2. So negative infinity to 2 union 2 to infinity. Now with our range. So our range, remember when we looked at rational functions, we had to deal with asymptotes. They were from the domain, and then we had to look at the degree of the numerator and denominator in comparison rules. Either they had the same degree, the top was larger, or the bottom was larger, and that would determine your asymptote. So the asymptote, the horizontal asymptote, would also restrict your range. In this case, we have the degree on the top and the bottom being the same. So the horizontal asymptote, or the line that would not cross, would be the ratio, so just 1 to 1. So we would have a horizontal asymptote of y equals 1. So this line, y equals 1, would not be included in our graph. So for our range, and the other problems, they didn't have this. We just had like a number on the top. So we didn't have a horizontal asymptote, or it was 0. Whenever the bottom is greater, there won't be 1. But in this case, we're going to have a horizontal asymptote of 1, so that would be removed from our range. So that would be negative infinity to 1 union 1 to infinity. So being that our domain and range are different, now we will get to see the domain and range of our inverse function, how they interchange. So we've got domain and range of f inverse. So we haven't done f inverse yet, but we do know we're going to interchange x and y, which is going to adversely interchange the domain and range. So what was my domain is now my range, and what was my range is now my domain. So this domain is the range of this function. So negative infinity to 1 and 1 to infinity. And then the range is what was the domain. So this will be negative infinity to 2 union 2 to infinity. So we'll get to see this actually now. All right, so I'm going to replace this y equals x plus 3 over x minus 2. We're going to interchange x and y to find the inverse. So we're going to have x equal y plus 3 y minus 2. I'm going to multiply both sides by y minus 2 to get rid of that fraction. So on this side, I'm going to distribute y times x. That'll give me xy. And then x times negative 2, negative 2x. Multiplying and dividing by the same thing will cancel each other out, leaving me with y plus 3. All right, we're going to move the 2x. So that's going to cancel, leaving me with x times y equals y plus 2x plus 3. We're going to move the y because we need them all to one side. I need just one y. We got two y's, which is a problem. So that's positive. I'm going to subtract it. So that will cancel. That will give me x, y minus y equal 2x plus 3. All right, we're going to factor out a y because, again, I need one y term. So factor out the y. That's going to leave us with x minus 1 equals 2x plus 3. And then if we divide by the x minus 1, that gives us y equal 2x plus 3 over x minus 1. So this is going to be our inverse function. Our f inverse of x. And we can kind of see, just looking at it, the denominator cannot be equal to 1. So in my domain, cannot use 1. And then if we look at, again, the ratio of x to y, they got the same degree. So 2 over 1 would mean 2 would be a horizontal asymptote. 2 cannot be used in the range. And that matches what we already knew. Okay, so inverse 2x plus 3 over x plus 1, or x minus 1. Just thinking about it. The domain of f, which is kind of off the screen, but domain of f, negative infinity to 2. So just our range here. Negative infinity 2 union 2 to infinity. I guess I'll just copy this one so whenever they ask me for the range, we can just paste it. So Control C. They asked me the domain of the other function. So domain of here, domain of the inverse will be, well, I can do the same thing. I can paste it and just change the 2's to 1's. And then the range is the same as this one. Again, I will change the 2's to 1's. And then the range of the other function would be given here. Alright, we're going to find out which one is the mirror image graph, or the graph and them on the same. Just looking at it is positive, so I would imagine that it would be here in quadrants 1 and 3. So C, but let's graph it and confirm. Alright, we're going to turn this on, go to y equal, clear out. We're going to graph y1. I'm going to just go ahead and make the fraction bar alpha, y equal, and enter. Avoids extra parentheses, so we're going to do x plus 3. I guess I got to do the x from here, x plus 3. And then x minus 2. So this will just be the original graph. I'll graph it and see what it looks like. Okay, so slightly shifted over, which we can kind of see that across that line. They're going by 30. This is a 1 to 10 axis. So if I want to see exactly this, I need to change my y and x scales, my windows. So I can say negative 30 to positive 30. Then negative 30 here to positive 30. And then this is just the first one. It's hard to see anything. So shift it out. Let's just go back to zoom 6 in our standard window. Alright, now I'm going to add the inverse. So I'm going to go y equal, I'm going to go down to y2, and I'm going to add the inverse function. The inverse function we have here at the bottom 2x plus 3 divided by x minus 1. Alpha y equal enter. And we're going to say 2x plus 3 over x minus 1. Alright, let's graph. Okay, so when you look at this graph, again, let me see if I can make this one full screen. That looks pretty close to what we're looking at for C. Nope, I want to close the whole thing. Can I cancel? Let's click OK. These have them in opposite locations. These are not in the right location. These are, but well, no, they're not either. So the only one that would match up would be C.